Hi, everyone. My name is Rick Lammers. I'm going to talk about a topic that I have been working on intensively, I would say, for the past 12 months, um, and it's LLM tool use. And what's difficult about tool use is that evaluating it requires understanding not just your use case, but also thinking about more complex interactions that you can have with an LLM. Who here, just to measure the audience, who here is familiar with JSON mode? A few of you. So JSON mode? JSON mode is a great way for structured data extraction. And there's been an ongoing debate between whether you should be using tool use or function calling or JSON mode. And I would argue that they're separate things and they can be valuable in different contexts because in my view, JSON mode is really about structured data extraction and tool use is really about detecting intent and planning. Because tool use rarely is just about retrieving information according to some JSON schema structure. It's about reasoning about the situation at hand and taking the right action. So I will be going over some of the ways in which you can measure this by looking at some of the great work that has been going on in the open source domain. So much of what I'm talking about you can find back online. I have some references in here. So who am I? As was introduced, I work at a company called Groq. We make our own silicon and we have very fast inference for LLMs. We do not only run LLMs on our Groq chips, we also run audio models. We're working internally on vision models. So really, we're a company focused on machine learning inference at large. Before this, I used to run a company focused on data ETL. Data ETL, I think, is still a relevant skill in this age of AI because at the end of the day, a lot of the AI productionization involves a lot of data engineering workload. So I really enjoy being kind of at that intersection of both of these because they really tend to come up both whenever you're doing real world application development on top of these AI APIs. Studied computer science and just really into kind of machine learning and combine theory with engineering. So why do we want to use tools? I think it's not only about like structured data extraction or reasoning, it's also about where do LLMs actually shine? So if you look at this example, it really is kind of like a super simple mathematical operation, but an LLM can still get this very wrong. So minus minus turns into addition, plus 1, so you would guess it gets it right, but it ends up with the answer 484. So really, I feel like we're maybe using the wrong tool for the job because clearly computers know how to do logic, right? We have much larger logic circuits than this motherboard operating at very high frequency, at very high accuracy, if not fully accurate with error correction included. So logic is really solved. Why is the LLM then struggling with it? And I think what happened in February 2023 was I came across this paper, was uploaded to arXiv. It's called Toolformer, Language Models Can Teach Themselves to Use Tools. And I think really it ushered in a paradigm of we should think about LLMs as systems that do certain things really well and other things not very well. And so we should be combining best of both worlds to build end-to-end systems, composed systems that have really good runtime characteristics on the metrics we care about, which usually is accuracy, but can be accuracy and some other measures like latency too. So what I'll show you here is, this presentation is JavaScript, so we can do some actual real prompting. And I want to introduce a concept called schema engineering, just so that we have a little bit of a background of like what kind of levers we have to improve the quality of tool use with language models. So if you look at this example, I say the literal prompt is what's the weather in San Fran, so I'm not saying San Francisco fully. And if I generate a tool call, you can see that it literally enters San Fran, right? Because the description of this tool isn't very prescriptive about what kind of generation it should be. So I have this, this annotation here and I say compatible with ISO 31662. Does anyone know what that means? I didn't know until today. So this is a standard for describing locations. So if you do this, the language model will actually kind of know, and let's see if let's copy this, reload the page, live demos, Reconnect the Wi-Fi. I was told Wi-Fi was going to be challenging, but I'm stubborn, as you can tell. Once more. Okay, Wi-Fi. So if the Wi-Fi were to work, it would generate a tool call that spells out the name fully. And just to say, when you're describing your tools, when you're giving the tools to the LLMs, it will afford you the opportunity to steer it to understand how to use the tools better. And so this is one of the important levers that you have. But of course, there's an innate ability for LLMs to either do really well on tool use or do poorly. And there's a really awesome project, and I encourage you to check it out if you're interested in tool use and you haven't seen it yet. It's called the Berkeley Function Calling Leaderboard. And you can't really make up much of this chart, but there's just to show there are many language models these days that support function calling. And there are also models, as you can see here in the dark, there's kind of like this area where some of these models really don't perform well, large differences between how good they are. So I want to give credit. You can check this out later. It's a project from Berkeley, and I'll give some examples, some actual data examples from this project on how they're evaluating function calling. So this data set is pretty much like the set of categories that they cover with their evaluation suite. And I just want to zoom in on a data sample. We just heard in the talk, not the previous one, but the one before that, you should look at the data. You should look what's the actual data. And I think it's good to see these data sets, these evaluations, kind of what's happening there. So this is a simple example. And any sort of model that claims to be able to do function calling should be able to cover this. So the question of the user is find the area of the triangle with a base of 10 units and a height of 5 units. And then it should be able to call this function that has 3 inputs and 2 required, base and height. Unit can be left unspecified. And then there is a correct answer. This is not very surprising. It's a simple tool call, and most models get this right. So it's a sanity check. We don't really get much information out of this. But the benchmark does more than this. So here we have an example where we introduce parallel multiple functions. And there's been some confusion about what does parallel function calling actually mean. And it really means that we can use multiple tools that are independent. So I think independent function calling might have been even more confusing than parallel function calling, but it really is about this independence relationship. And I'll try to go to more examples, and I think we're going to really reach a point where we should have a discussion about what kind of paradigm for function calling or tool use for LLMs is actually the right one, because we have some limitations with the current paradigm. And I won't say it's because of OpenAI, but maybe it's kind of because of OpenAI. So in this example, we need to call 2 functions, but it's clear from the semantic understanding of this sentence that the mean and the latitude or the time zone associated to this longitude and latitude are independent questions. We don't need to know one before we can calculate the other. They're independent concepts. And so you could argue that any model could generate the request to use these tools at the same time. And another example is if you have a function that is specified that looks like it could answer the question, but it's just kind of related and not actually the right tool to use. And what it should do instead is it should try to answer without using this tool, using its own reasoning capability. In absent of any tool that it has access to, it should do its best to answer the question itself using reasoning that the model does possess. So in this case, the park area is not a way to calculate the sphere volume. And so a good result here should not invoke this function. So that's the relevance detection part of this benchmark. And again, with JSON mode, it's more like, does it generate the right signature? But it's really about reasoning capability over the provided tool and the context of the question. It should identify that this is not the right function. So another area that we see kind of a lack of performance from state-of-the-art LLMs is in follow-up detection. So if you have the right tool available and the question of the user is one that is relevant to the tool, maybe calling the tool still is not the right thing to do because you lack information. And so this is not included in this benchmark, but it is a really common problem where the model will hallucinate some of what the user might want, but instead it just assumes that the user wants it, and that leads to undesired outcomes as the model operates in like a chat context and calls these tools. So in this case, book me a flight to New York for next month. It doesn't mention the departure city, the number of passengers, or the class that they want to book for. And so what you want is for an LLM to not be overly eager and always call the tool if it's the right one, because it's clearly relevant to the question. It should reject and ask for more information. So all of these subtle nuances are required for a high performance, but are often not measured in like structured extraction type benchmarks. And again, it comes back to the beginning of my talk of like, it's really about intent detection, reasoning about the situation, and then taking the right action. For sequential is this other interesting kind of situation where you could potentially confuse this with parallel function calling, where you think you need to call multiple functions, which you need to, but you cannot do this until you have the answer of a previous tool call. And so the current paradigm of function calling using the OpenAI API is the one of kind of tick-tock. So it's like you tick, you get a tool that needs to be invoked, you produce an answer, and you talk, you kind of pass the answer back, and then you tick again. So you get another chance to ask the model to call the right function. With this prompt, what is 8 times 6 to the 5th power plus 9? If you only have these operations at your disposal, multiplication, addition, and exponentiation, you need to first figure out what to do, then take the action, calculate the result, pass it back to the model, and then ask again for the next tool invocation. So if you don't do this, what actually happens in models that do tool use poorly is they will hallucinate, or they will try to like nest somehow like the tool calls and say there's a reference to the answer of the previous tool call, because they kind of know that they're dependent on the result of the previous tool call, but also they don't have that result yet. So it's kind of like this paradigm mismatch where asking a question in this way almost doesn't give the LLM a way to do a good job unless it just respects the fact that it can only move one step at a time for any sort of forced sequential operation where there's strict dependence on the previous result of a tool use, if that makes sense. So finally, I want to talk a bit about what could an alternative paradigm look like. And I think Microsoft has released a really interesting project. They first demoed this in November last year at the AI Engineer at the Engineer Conference in San Francisco. And it's this notion that you could also do tool use in the context of TypeScript and program generation. So maybe we should recast this idea of function calling by language models as code generation. Because with code generation, we not only get something specified about the inputs to functions, which is what the current OpenAI paradigm promotes with the JSON schema that you see that describes the arguments of a function. It also says something about the data flow of the program and whether that's valid. So in this case, you have two functions that are both independent. They're both two multiplications of constants. So these can be called at the same time. And we have a dependence relationship, but we also have a type guarantee that the inputs to this final function can only take a certain type, namely number. And so this specification of knowing exactly what these previous two function calls yielded can then be used to guarantee that the next invocation is going to operate on inputs that are type safe. And we care about agentic programs, and we care about reliability of those. But if we don't have type guarantees, then how are we going to ever get to accuracy? We just need to like hope that an LLM never makes a mistake, but we know they're not capable of that. So finally, just kind of this friendly dig because OpenAI does push the field forward and they get a lot of credit for that, and I think they do. But I don't think that this API, even though we fully support it at Groq because we want to be OpenAI compatible because widespread adoption leads to good ecosystem compatibility and we see the advantages, we do want to challenge everyone, and especially in open source, people who are willing to tinker, to think about this paradigm and ask themselves, is this the right paradigm or should we be standardizing on something else? That's it. My name is Rick. You can follow me on X. Thank you very much for listening. And then we have some time for questions, so. I think it's an interesting question because it's not clear to me how you would directly compare type chat's performance to code generation. I think you pose an interesting secondary question, which is for code generation, do we really have good benchmarks other than like being able to implement a program end to end? But implementing a program is different to like reasoning in the context of a chat conversation, which is what typically tool users refer to. So I think you point to a really interesting transition point where when does tool use become program generation and how do we evaluate both? And if we evaluate both differently, what's kind of like the in-between way to measure these things? So I think it's an open question, and I think someone that could quantify code generation capability for tool use, that would be really interesting. But I don't know if anything, so if you find anything, let me know.
How do you imagine the integration of like the follow-up tool with the type chat? So how do you imagine those two are integrated?
So what you see in the type chat library is that once the program has been generated, so what it effectively does is instead of it being able to generate just one tool or multiple tools that can only be called in parallel, which is what OpenAI limits you to do, it allows you to generate in one go a small computational graph where you have multiple tool uses that depend on each other. And the way that works is it generates the entire program. It then first checks the type safety. Once the type safety has been guaranteed, it will run the program, produce the final result of the program, and pass that back to the LLM. And what you see in practice is that that allows you to, in one single back and forth, have more complicated tool use enabled because it allows you to have these use cases where there is dependence between the tools that are available and need to be used to answer the user's question. Does that make sense? Okay, cool. We can talk.
Trying to get the power on right now.
Okay.
Sure.
Function calling requires multiple API calls, and the error rates would then multiply, basically, right? So if you get the first call, if not 100% correct, then the error rates would multiply across multiple different calls. How do you set up a system to kind of guardrail the accuracy of like a series of API calls?
Yeah, I think it's a really good question because if you look at the type chat example where you have multiple calls that maybe depend on each other, doing that correct seems harder, and I think it's because it is, right? It is harder. So what you could do is you could limit, you could still say only generate at most 2 layers deep where the result reuse is not like too nested. You could also limit the total number of calls to kind of bound the complexity. But I think in order to compare apples to apples, a system that supports maybe like the complex tool use like type chat versus the more simpler OpenAI based tool use, you could look at end-to-end task completion. So what's really nice is that typically you can write benchmarks where a given task is specified for the user and that user knows exactly what they want in the end. You can know exactly what the number should be. Like with a calculation, like the example was, you could just know, can it arrive at the right answer? So you can kind of measure end to end, even though the implementation detail is like 2 very different ways of doing function calling, if that makes sense.